Kia ora Year 12. This is the first of the videos I'm going to make looking at all of the vector questions in the old A-level papers. There are some really great problems in here, and this is the first one. So this is from 2017, and it's paper 32, question 9. I'm just going to do part 1 in this video because I'm going to go quite slowly, and I don't want the video getting too long. So just have a look at what we've got. We've got a position vector A, and that's given by this. And then we've got a line L. So we've got the vector of equation of a line. The first thing we have to do is find the position vector of the foot of the perpendicular going from A to L. And then we have to take that and reflect that line segment in the line and find the position vector of the reflection. Now that sounds hard, but that's actually a really straightforward thing to do. If you just have a decent diagram in front of you. So we're going to start by doing that diagram and giving labels to some of the points we need to find. Right, so apologies for the shockingly bad diagram, but here we go. This is the origin. Okay, and let's put point A here. So that's position vector A, and we've got a line somewhere out here. So we need to find, first of all, the perpendicular from A to that line, and we're going to call that point X. Then we need to take point X and we're going to reflect it somewhere out to here, and I'm going to call that point Y. So what do we know if we've got perpendicular vectors? Well, we know that their dot product is equal to 0. So first thing to do is to rewrite everything in our usual form. So OA is I plus 2j plus 4k. So we'll write that as 1, 2, 4. And the line has got, the vector equation of the line is 9, negative 1, 8, plus mu times 3, negative 1, and 2. So what we're going to be doing is figuring out which value of mu, where on that line, is this going to be perpendicular to this. So we're choosing a value of mu. So as soon as you see that, it gives you a pathway for what to do next. Right, so we want to have from A to X, the vector from A to X, and the direction vector of the line, which is given by 3, negative 1, 2, they need to equal 0. So for perpendicular vectors. So we now need to figure out what is the vector from A to X. Well, X is the point on line R with parameter mu. And if we start at A, that gives me the following vector. So we're going to have 9 plus 3 mu minus 1. Negative 1 minus mu minus 2. 8 plus 2 mu, take away 4. Right, so what I'm doing there, this should feel very easy, is getting my components for x, y, and z for any point on this line. Right, and then taking away my starting point, which is the vector, the position vector for A. So we get a vector for AX of 8 plus 3 mu, negative 3 minus mu, and 4 plus 2 mu. Now we need to take that vector and figure out the value of mu, so solve for mu to give me a dot product of 0. So that's step 2. All right, so this is what you should end up with when you've worked out that dot product. We now just need to collect up like terms, and we get 35 plus 14 mu is equal to 0. So mu is equal to negative 35 over 14, and dividing that through gives me negative 5 over 2. So mu equals negative 5 over 2. So that's now going to tell me where the foot of the perpendicular is. So to find the foot of the perpendicular, be really careful. We're not going back into here. We're going all the way back to the point on the line. So I'm going to scroll back up and show you what we're substituting into. we want to substitute right back into the start, into the equation of the line, right? Because we've now found the value of mu, the point on that line, that is going to be perpendicular with the vector OA. So going back to my diagram here, we know now that x will occur where mu is equal to negative 5 over 2. So we're going to find the position vector for x. Right, so when we substitute in here, x will come from this, 9 plus 3 mu, negative 1 minus mu, 8 plus 2 mu, giving me 18 minus 15 over 2, negative 1 plus 5 over 2, and 8 minus 2 times 5 over 2. So what does that get me to? Well, that gets me the foot of the perpendicular at the following position vector. All right, and we could write that back in I and j format. So 3 over 2i plus 3 over 2j plus 3k. Right, so that's the first part of the question done. Now let's look right back to what we were asked to do to start with. So we found the position vector. I think that's worth 3 marks. And now we have to find the position vector of the reflection of A in L. So I think the easiest way to do this is to look at what's going on here in the graph. We know where point A is. Right? Point A is at 1, 2, 4. Going back to coordinates. And we know where x is. So x has coordinates 3 over 2, 3 over 2, and 3. So if we want to find the reflection, because this is perpendicular, all we have to do is keep on going out here the same distance. So you can do that with coordinate geometry, or you can just do it by looking at how far you went and going that far again. So what happened from here to here? Well, we went up by a half. So we're going to go up by another half. So y will be 2. The x coordinate will be 2. What happened with the y coordinate? Well, we went from 2 to 3 over 2, down by a half. We go down by another half and we get to 1. Lastly, the z coordinate, we moved from 4 down to 3. So for the reflection, we're going to go down another 1 in the same direction. And we get 2, 1, 2 for the coordinates. And we asked for a position vector. So we're going to write 2i plus j plus 2k. Or we could write it like this, 2 in column form, 2, 1, 2. All right, so that's all for now, but that's plenty long enough. I'll come back later on and do parts 2 and 3. Thanks for watching. Let me know if you've got any questions.